Okay, hello everyone. I think today it will be quite brief, probably less than 10 minutes. So my topic today is giving semantics to web services with JSON-LD. I guess I should start by what I mean by web services. It's kind of a broad term. But anyway, web service is a service that an information system on an app or an application can provide to various kinds of clients over the web. There's several types of web services. The most, I guess, canonical would be the SOAP web services, which are based on on a standard. But nowadays, the most popular way of creating or developing web services is using the representational state transfer design or architecture. It's not a standard, it's just a set of guidelines and best practices. And I suppose you will know the shortcut for that. It's called REST. It's based mostly on or mainly on HTTP principles, so it's very simple and it's easy to understand and easy to use. And basically, you can have a web service that serves multiple types of clients. It could be an information system, some portable device, a phone or whatever. Oops, sorry. Or a web or a UI of an application, which is what happens quite often nowadays when you have a web service serving a JavaScript-based front end of an application. The problem with such web services, which usually nowadays publish the data and consume the data in JSON. Earlier, it was also quite often XML, but XML is quite verbose. So nowadays it's mostly JSON, which is also which goes hand in hand with the JavaScript-based front ends, because JSON is JavaScript object notation, so it's very easy to work with in JavaScript. And the problem with that is you need some prior knowledge or understanding of what the web service is supposed to do, and a human has to have that knowledge, because if you just try to read the JSON, you have no idea or very little idea of what the data might mean. So if you look at this example, I guess you can presume that the ID attribute will be an identifier of the object. It has some arbitrary value. If this value is globally valid, or if you have a relational database under the system, then you will have probably another table which can use the same identifier for a completely different entity. What the children mean, the attribute itself and the values of that attribute, again, that's quite questionable. Internationalization of the data is also quite difficult in plain JSON. So and if you have the the web service, then yeah, you can guess what the data mean. But if you just get this data, it's a lot of guesswork. So what you can do with plain JSON is replace it with JSON-LD, which is JSON for linking data. It has many uses, but for our purposes, it is that it gives or allows you to give context to the data, which basically means that you can describe the meaning of the data directly with the data, so you don't have to query some additional service which would provide you with the explanation for what the data means. So here we have the same data sample as in the previous slide, but now we have added the context, and we used capabilities of JSON-LD to also enhance the data. So now we use URI identifiers, which are globally valid. So this ID for this object will be always the same, and you can reuse it in other systems. We can now tell what the type of the object is. We can use internationalization for the attributes of the object. We now have we now know what the attributes mean because the context tell us that the children attribute actually corresponds to a scos property called narrower, and you can go, you can actually reference this URL and see what narrower, what scos narrower means. And we now see that the children are basically just identifiers of other objects that you can then retrieve. So JSON-LD is quite handy, and also it is still a valid JSON. And if you don't think about the context, it's basically it's quite nicely backward compatible. I actually did some mistake in this example because I could have put the ID and type in the context as well to make it look even more regular. So I could have just an ID attribute without the at. The same for the types to make it look more like a regular JSON. So that's another benefit of using JSON-LD, that if you have a client which doesn't understand the context, that's no problem. It's still a valid JSON, and it can use the same attributes as if you used just the plain JSON without the context. Yeah. So the problem is now, how can we use JSON-LD in REST web services? And there's a couple of approaches that you can have with this. If you have triple store underneath your application, you can basically all of the RDF access libraries like RDF or JGenna, or in other languages, they can produce JSON-LD without any problems, because JSON-LD, among other things, is a serialization of RDF. So you can just produce directly JSON-LD. The problem with this, or a slight problem with this, is that it's quite, you have to make some efforts to produce domain objects, because your application presumably works with some domain objects like a person, an organization, or whatever. So you would have to structure your queries so that the data that you produce in JSON-LD correspond to these domain objects. Yeah. Another option is, if you already have the data in the application in some domain object, you can actually generate the JSON output directly using libraries like JSON-LD Java or Titanium. But it takes quite a lot of boilerplate code to do that. So what's probably more efficient and more effective is to use a library which contains this boilerplate code for you, and just maps the entities or DTOs to JSON-LD and back. Yeah. And one such library, what a surprise, is JB for JSON-LD, or Java binding for JSON-LD, which basically allows you to have this regular POJO with some annotations, and the library will then produce the JSON-LD and also allow you to do the other way around. So you get some JSON-LD and it will deserialize it into Java object based on the annotations that it finds in the class. Since the library started in our research group, we reused the annotations that we have in JOPA for annotating entities. So we have a class which declares the type, ID for identifier, and the various all annotation object or data property annotations for the attributes. So what's nice about this library is that it's very easy to use. I will show you a demo in a minute. The mapping is declarative, so it's very easy to understand, and it's quite clear. It supports polymorphism in this serialization. So if you, for example, have have a class person, and it has subtypes like user and employee, for example, and you get some JSON-LD data with the types attribute, which tells what kind of object it is. Then you can ask just for type person, and it will actually instantiate the correct subclass based on the type in the JSON-LD data. So that's quite nice. I think you can write your custom deserializers and serializers. It is modular. So currently there is a module for integration with JSON, but just as well we can have a module for integration with JSONP or any other JSON library for Java. It also supports all of the nice JSON-LD features that I was mentioning before. So it works with the context. It supports language text, strings, typed values. I will show you again in a minute. Object types. That's the classification of the object, and also object references, which could quite nicely reduce the amount of data that you are passing to and from the web service. It also supports multiple JSON-LD forms, both on the input and on the output. But what you are usually mostly interested in is the input, so you can pass compacted or expanded JSON-LD to the service or to JB for JSON-LD, and it will work with it without any issues. And it also, as of last week, also supports embedded context, so that allows you to override term mapping. I guess I can show you that in the demo as well. There are some alternatives for this library. Hydra Java, Pinto are Java libraries for this. LDFlex or Calamus are for different languages. So let's see some demo. So the first demo is basically a minimal setup for the library. So basically, this is the integration with JSON that we have. So this is more or less everything that you need to do to work with JB for JSON-LD in an application. So you create an object mapper, which is a JSON object. This one you don't need. This is just for the demo purposes, so that the output is pretty printed. This one just tells the JSON to ignore any unknown properties when it's in the input. This is probably the most important line. So you instantiate the JSON-LD module, which is the module of the JB for JSON-LD integration for JSON, and you register the module with object mapper, and that's pretty much all you need to do. This other line just tells it that we want to output the data with the context. Now there are some pre-prepared samples of the data and serialization and deserialization. Basically, the output then looks something like this. So if you run it, for example, this is a serialization of a single object. So you get the context, and then you have the data. I think you can also try some more complex, like let's say an organization, which will have some references to the data as well. So now we get here's again the context. Here are the typed values. So we can say that the created attribute corresponds to this property, and the type of the value is an XSD date time. So you know that the value of this attribute is date time or timestamp. So now here we have the data again, URI types, some basic attributes, and now we have references to other objects. And what's interesting, and that's using another of the features of JSON-LD, which is built in JSON-LD, is we have a backward reference back to the organization. Yeah, so you see the identifier is the same, and we don't need to do anything to tell the library that this should just be serialized just an ID, just as an ID. If you used it with plain JSON without any specific configuration, it would go into Stack Overflow because there is a cycle of the references, and without some configuration, it would just loop in this attribute. But with JSON-LD, it automatically recognizes the loop, and it actually just adds the identifier here. And here are some other attributes. So this is the first demo. It's very simple. It's a part of the repository with the source code for the JSON integration. There is some explanation of what you can do with the demo. And another demo that I have is I added JB for we use JB for JSON-LD in Termit for quite some time. But I have been experimenting with the context support that I implemented for JB for JSON-LD recently. It's not in the production version of Termit yet, but this is basically how it looks like, the output of it. So we have again, we get the context. So this is listing root terms in this specific vocabulary. So we get the context, and here then we have the list of terms or root terms in the vocabulary. So again, you can see that we use the simple JSON names. These are again references, backward references to the vocabulary. And I think I'd like to see some other references, but I don't know if I will find them. The same for the glossary. You can see that the glossary is appears here multiple times. Basically, for every term, there is a reference to the glossary. So we are not repeating the glossary everywhere. We just use the reference to the glossary. It's very, very simple. So I think that's pretty much all the important stuff that I wanted to show. Actually, I think I can show you one more thing, and that would be if I use this one. Okay, so it's not called locality, it's called localita. Yeah, it's called localita. Here we will be able to see the embedded context at work. So I think at least. Oh no, it's localita, and it's the history of localita. History, yeah. So what you will see here is that we have a bunch of change records for the term. And what happens here is that the change records contain the old and new value of an attribute. But the problem is that the change records are for all the attributes of the entity. So sometimes it's a string, sometimes it could be a reference to another object. So what happens here is that the first time we encounter a change record, we put the term mapping into the context. So we see that the first change record was some string attribute which contained a language string, and that's the term that's registered in the context. But if we go down the change list, we will actually find a change that is not or whose value is not a language string. And in that case, a new context appears, which overrides the mapping from the top level context. And here we just say, okay, the value is still, or the URI is still the same. It doesn't have to be, but in this case, it's the same because it's the same class. But the value now is not a language string. It's just a Boolean. Yeah. So that's what embedded context mean. Again, this is the same. We are just declaring the context to override the parent context. So that's what's new also in JB for JSON-LD. One more context-related feature that's still missing at this moment is the ability to use external context, where you would just say, use the context from this URL. And in that case, you wouldn't have this context value here as an object, but it would just be a URI to where the context can be found. Okay, I think that's all. That's pretty much all. Here are the links to the Git repositories. This one is for the core implementation, and this one is for the integration with Jackson. Uh, Library is available on Maven, and the wiki page on GitHub also contains some basic info. Okay, that's it. Thanks for listening. If you have any questions, shoot.
Okay, thanks, Martin. It was very nice. Uh, I was not sure if I understood the last part about embedded context. So if I understood it correctly, you had some property of value, and it was global for whole output, but then you had embedded context which overrides the this global value, right?
Yeah, exactly,
Okay,
exactly.
okay, and how did you compute this? Why did you decide at the first place to have this
Yeah.
global context like this and not the Boolean value? Or how do you
Uh,
compute this?
yeah. This currently is done just by what you encounter first when serializing the object graph. So
Oh, okay.
if the change list or the list of the objects that was being serialized had a different order, where the first one would be a boolean, then it would the global context would contain the boolean one.
Mm-hmm.
It's a I mean for this particular case is a bit strange, just because the object class hierarchy is very weird. But in general, it's used like if you have a class and it references another class, and that other class uses the same name, has a field with the same name but a different type, for example, or different mapping. Then that's where these embedded contexts come into play. I'm trying to find the embedded context. Yeah, this is basically what I mean. Yeah, so the global context declares some term. Where is it? Fuck. Hold on.
Oh, okay. Yeah, I get it. I get it.
Yeah, it
Get it
was
enough.
thinking where the original. They have a nice example where that's basically just overriding the property mapping.
Mm-hmm. Okay, maybe I have a question. Let's say I have list of I don't know, person and car.
Oh yeah,
Uh,
this is. Oh, sorry, I'm sorry. This is the example. Yeah. So for example,
mhm.
here you declare the name to be example.com
Yeah.
person name, and now we override it with organization name. Yeah. Sorry. Go ahead.
Yeah, let's say that you have. What is not clear to me is how, if there is an annotation for that or how it works. So let's say if I have a list of person and car, and this car has even two types, car and vehicle, and I just serialize it. I get two embedded contexts because it's list or because it's not same type, right? But how do I choose whether it is machine or car, for example, in this one element? Is it
Um,
annotation in Yopa object there, or how do I?
I I don't think I understand what you mean.
Yeah, okay. So let's say I have a list of two elements. It's person and car.
Okay.
But this car has also another type, which is which is machine.
Like type in the types attribute.
Yes, yes,
Okay,
yes.
okay,
And now I serialize it. Then I
okay.
have two embedded contexts. One will be for person, one will be for machine, or there will be one global and only one of them will be overridden.
Well, not necessary. Only if there are mapping conflicts. But yeah, you might have.
Oh, maybe I'm mixing two things together. Okay. So in the list, so maybe I should not mix it with embedded context. So in the list, how do I decide whether it should be machine or car? So maybe forget about embedded context. It's not issue of that.
And in the list, you mean when you are trying to deserialize it, or
Deserialize it. No, serialize.
well, when you are serializing it, you have the runtime information from Java, and it's the class that you have an instance of person and you have an instance of vehicle or car, and so and the classes of course need to be annotated by all class, or actually they don't need to be annotated with all class, but in that case they have to have the types attribute. So either you have an all class annotation or you have types attribute, or you have both. That's no problem with that, but yeah. And so the type in JSON-LD, the add type, will then contain a merge of both of these. So if you have an all class, then it will use the all class value plus everything that's in the types attribute.
Okay.
If that's what you ask. I think you can actually see it if you look here. You can see that the term localita or locality has two types. One is the Scos concept type, which is the type mapped by the entity, and this one is the UFO object is the type which is assigned to it via the types attribute in Java, the JOPA types attribute. If
Okay.
that's what you are asking about.
Partially, yes. Partially, yes. Okay.
Okay,
Okay. Okay. Thanks. Thanks.
sure.
Maybe I ask one more thing. What's the plan for embedded context? Like, sorry, not for embedded, for external context.
Uh,
Like, do you really need it somewhere so it will happen soon, or rather not?
well, we don't need it necessarily, but it's like it's a it would make the library more feature complete, I would say. Like the same was with the embedded context. Actually, if you were to look at Termit as it is right now, it doesn't use context at all. It uses the full URIs of the attributes. So if we go to uh, Termit dev again, and if we look at the output from the server, it's not using contexts at all. Yeah, it's using the full URIs of the attributes. So the embedded context was basically just, or context at all, was just another feature that I thought, yeah, this should be here because it would make it even better compatible with plain JSON APIs. I could say. Then the embedded contexts were basically like, okay, we have a conflict here, so we need to resolve it somehow. And the original way was just to throw an exception and refuse to serialize it at all. But of course, since JSON-LD has a feature for that, or a capability of handling that, then the library should support it as well. External contexts are basically the same thing. We don't need them necessarily, but it's I think it's a nice feature.
Yep, it would make it really like nice, the
Yeah,
API. Yeah.
yeah. So yeah, I guess that's next thing on my to do list for the library. Whether I will work on it very soon or not very soon,